Hello and welcome. Curious about data science and its real world impact? In this session, we will explore how data transform into insight, different types of data, and the importance of asking the right question. Key topics cover data dispersion, quarterlies, variance, and standard deviations, outlier detection, impact, and visualization using box plots and IQR. Correlations, Pearson versus Spearman and their differences, visualization, scatter plots, box plots, and heat maps. Real world application learn how to analyze and visualize data efficiently. By the end, you will think like a data scientist and uncover meaningful insights. Let's get started. Understanding data dispersion. Dispersion measures how data spread from the center. Average likes the mean are not enough. We must understand the variability. More dispersion means higher consistency. Key measures are range, IQR, variance, and data deviations. Data dispersion helps in identifying pattern in dataset. If the data is widely spread, it means more variability. In HR, this can reflect salary disparities, performance variation, and employee retention pattern. Case study, employee salary distribution. A multinational company has employees across different departments. The HR department want to understand the salary dispersion between two key departments. Department A, let's say marketing, salaries are relatively close together between 50,000 to 60,000. Employee earn similar pay indicating low dispersion. Department B, engineering, salary range from 45,000 entry level to 1,050 for the senior roles. There is a large gap between the highest and lowest paid employees, showing high dispersion. So, if even if the average salary is both department is similar, department B engineering has much higher salary variation, which can cause dissatisfaction and retention issues among employees. So, what HR do? Companies should analyze salary dispersion to ensure fair compensation, employee satisfaction, and retention. So this is the code. So first we import necessary libraries, and then we have define the marketing and engineering departments, and then calculate standard deviations and create a box plot. And then we have a customized colors and grid labels and display standard deviations, and then we show the box plot. So here salary distribution you can see from marketing salaries and engineering salaries. So salaries do not match very much from here, and then we have employees earn similar wages, making the pay structure more uniform and predictable. And then engineering salaries are huge variations. Some employees earn much more than others, and there could be lead to discontent among lower paid employees. And what are quarterly divided into four equal parts to analyze distribution. Quartile. So first is 25% of the falls below this value. The second Q2 is the middle where the half of the data lies within half below. And got 3 is 75% of the data fall below in these values. So example has we evaluate them in the next slide. So we have libraries, then sample data set, and then compute, then create a box plot and annotate the quarterlies. And then we have our labels. So this is the results using data set 10, 20, 30, 40, 50, 60, 70, 80, 90, 20. So whisker is around 10 and the maximum value is 100 and this one is a 10. There is no outlier in the data set. So the blue label is Q25 and mark the 25% percentiles of the data set, and the red label is median is 55 and mark the 50th percentile, which is always a median, and the third one is 77.5 is a Q3. 5 number summary provides a quick overview of data spared. The minimum lowest value in the data set, the smallest data point, Q1, 25% percentile, 25% of the data falls below this value. Q2, median value, the middle value of the data set. Q3, third, 75% of the data falls below this value. And maximum is highest value in the data set, the largest data point. So 5 number summary, we have again important uh, libraries, then sample data set, and then we have a 5 number summary. Print the 5 number summary here and create a box plot and annotate the 5 summary of the graphs. And then labels have a titles. So this is the results. So minimum is 5, Q1 is 10.5 and median is 23 and 33.75 with Q3 and the maximum is 50. What are the outliers? Are the data points that significantly differ from the rest of data set. These can arise due to the measurement error, fraud, or natural variation in data. So there is a type of outliers. Number one is global outliers. These are the extreme value that deviate significant from the overall pattern of the data set. They represent anomalies that are far from the rest of the data. When explaining global outlier, emphasize how they are values the fall from the outside the usual range of the entire data set, signaling something worth investigating further. A banking transaction data set where the average transaction is around $100, but one transaction is recorded as $10,000. This $10,000 value is an extreme outlier compared to the rest of the data. Contextual outlier. These outliers are not wrong, but only seems anomalies when placed within a particular context or time frame. These outliers are unusual only when observed in a particular context or environment. A value might seem normal or its own, but is considered an outlier when viewed through the lens of a specific situation or time frame. Example is a temperature reading of 40 centigrade during the winter month is considered a contextual outlier, while 40 C may be normal temperature in the summer. In winter, it's usually high and a contextual anomalies. Collective outlier, these are the group of values that together deviate from the general trends or pattern. Individual values in the group may not seem like outlier, but when considered together, they represent a distinct deviation. A stock market crash where multiple companies experience a sudden and simultaneously drop in prices, such as what happened during a financial crisis, can be identified as a collective outlier. So this is statistical methods for outlier detection. Method 1, Z-score. So we have libraries and the one is Panda, for numerical computation, for handling data in tabular form, for plotting graphs, enhanced data visualizations, and calculating zero score. And then we have a simple data, which is outlier is 400 is a outlier. Convert dictionary into pandas data frame and compute z score for each data point and calculate deviations. Outlier, we identify outliers, make marks values yes if their absolute 0 is greater than 3. So print the data frame with calculated zero score and outlier labels, and then we print it. So the box plot showed the distribution of data. Most of the values are clustered from 10 to 15. The outlier appears in a 400, far from the rest beyond the whisker, and this confirm 400 is extreme value compared to the rest of the data set. And Z score, we say that each blue dot represent a normal data point. The red dot is indexed to a correspondence with the value 400, which has a zero score much greater than 3. The historic horizontal dashed line is a z is equal plus 3 and z is equal to 3, marks the threshold beyond the data point as considered as outlier. Since the z score is 400 is significantly above the 300, it is classified as an outlier. Method 2, IQR methods. The IQR method detect outlier by analyzing the middle 50% of data and identifying extreme values beyond 1.5 multiply IQR. The IQR method is a statistical technique used to detect outlier in a data set. It focuses on the middle of the 50% of data and identifies value that lies significantly beyond this range. The IQR is calculated is IQR equal to Q3 minus Q1, where the Q1, the value of 25% is data false, and the 75% in Q3, the 75% of the data false. Outlier detection rules. Outliers are values that fall too far from the middle range of the data. So any value that is below Q1 minus 1.5, IQR 1, and then above is if there is a Q3 plus 1.5, IQR is considered as outlier. So why use the IQR method? Unlike other methods like standard deviation, it is robust against skew distribution and extreme values. It is widely used in data analysis, finance, and machine learning to clean and pre-process data set. So same, we have import the necessary libraries, then the sample data, and then commute from 1 to 3, define outlier thresholds and outline data frame, and big plus visualization to show outlier and display the data frame with outlier identification. So this is identifying outlier at any values QR minus 1.5 are above 1.5, IQR and outlier. These are the marks yes in the outlier, and this is the 4. Any value Q1 minus 1.5 are above Q3 plus 1.5 equal is the outlier. Method 3, isolation forest, unsupervised learning. Isolation forests work by randomly partitioning the dataset and detecting anomalies as they are isolated early. Isolation forest is an unsupervised machine learning algorithm using outlier detection. It works by randomly partitioning the dataset into smaller subsets. Anomalies mean outliers are detected as those data points that get isolated early in the partitioning process. How it works. The algorithm constructs a random decision tree by splitting the data. Normal data points require more splits to be fully isolated. Outliers are isolated quickly because they lie from the dense data regions. The model assigns an anomaly score to each point, classifying extreme values as outlier. Why use isolation forest? Efficient and scalable, works well with a large data set. Unsupervised learning, no need for label data to dataset anomalies. Effective in high dimensional data, perform well even when data has many features. Real world application, fraud detection, identifying suspicious banking transactions, cybersecurity, detecting malicious activities in network traffic, healthcare, finding abnormal patient record in medical diagnostics. So that is again we have libraries, isolation forest from skitlearn. Step one, create sample data, initialize the isolation. The model assign anomaly -1 and for outlier for on normal points. Outliers are those is a 400 again we have 400 and anomalies red dot is are the anomalies that are pointed as detected as a outlier. Normal data blue one is out inside the expected range and the green dot lines represent the average value of the data set. Understanding box plot for outlier detection. How to read box plot? Box IQR, the box represents the middle 50% of the data from IQ to I3. The wider the box, the greater the spread of the data. Line inside the box, median 2. This line represents the median 50% percentile. If the median is closer to Q1 or Q3, it indicates skew distribution. Whisker lines extending from the box. Whisker extend the minimum x maximum values within 1.5 multiply IQR range. This helps shows the range of data set without considering extreme values, I mean outlier. Dot outside the whisker outliers. Outliers are the data point that fall significantly outside the expected range. This indicates potential anomalies, error, or extreme variation in data. Understanding box plot, the outlier detection. Why use box plots? Quickly identify outlier in data and compare distribution between multiple data sets. Data detect skewness, whether data is symmetrical or skewed to one side. Summarize large data sets efficiently without listing all values. Real world applications of box plot, finance, detecting stock market fluctuation, identifying anomalies in transactions, healthcare, analyzing patient data like blood pressure levels, glucose readings, quality control, monitoring product consistency in manufacturing, education, and understanding student performance variability in test score. A box plot is an essential tool for data visualization, helping analyze and represent interpret data distributions, spot anomalies, and compare multiple datasets efficiently. So understanding box plot for outlier detection. So celery is and create a horizontal box plot with enhanced vertibility. Graph is 42,000 to 85, middle of the age, this one, and the median line 60,000. Half of the employees earn below this amount. Whisker minimum maximum excluding outlier extend from 35,000 to 1 lakh. Outlier dots beyond whisker 120,000 to 150,000 is the outlier. Standard deviation and variance. Variance and standard deviation measures how data diverts from the mean. Higher standard deviation, more data spread. Low standard deviation, data is clustered around the mean. Variance and standard deviation quantify variable in data sets. They are useful in understanding salary inequality, employees attrition trends, and performance consistency. Standard deviation is preferred over variance since it is the same unit as the data. Case study employee turnover, and so this is the employee attrition data for 2 locations. Compute standard deviation and plot data to visualize dispersion. So location A, lower standard deviation meaning consist iteration, and the B is the irregular turnover. So box plot helps visualize dispersion. Wider boxes indicate greater variability in iteration. HR can these insight to identify problematic locations and implement stability strategies. Lower standard deviation suggest a stable workforce, while higher value indicate burnout, dissatisfaction, and mismanagement. Variance versus standard deviation. Variance spread in squared units, salary squared, making interpretation difficult. Standard deviation, square root of variance, giving result in the same unit as the data. Understanding correlation. Correlation measure the relationship between two variables, helping us understand how one variable changes in relation to another. Just because two variables are related don't mean one causes the other. Type of correlation, positive correlation, as one variable increase, the other also increase. A strong positive correlation means that one factor increase, the other follows. Height and weight, taller people tend to weigh more, and higher study hours, better grades. Negative correlation, as one variable increase, the other decrease. A strong negative correlation means that one factor increases, the other decreases. For example, exercise and body fat. More exercise lead to lower body fat. Higher stress mean low productivity. No correlation, no relationship between the variables. If there is no correlation, changes in one variable, no effect of the other. Example is your shoe size and IQ, completely unrelated. Correlation is a statistical tool used to measure how strongly two variables are related. Just because two variables move together does not mean one causes the other. Example, ice cream sales and drowning incident may both increase in summer, but eating ice cream does not cause drowning. So the Pearson correlation coefficient measure the strength and direction of a linear relationship between two variables. It ranges from -1 to 1, and this is the formula. Uh, Now we need to understand our values are. One is two variable increase or decrease together perfectly. Then one variable increase while the other is decrease, and the 0 1 is no correlationship linearship between the two variables. So let's apply on the world, and that is the strong -1. -1, 9 is a strong positive correlation, height and weight, tall people and weigh more, this one. And the strong negative is daily exercise and body fat. More exercise lead to lower body fat. And the 0 is no correlation, IQ size and unrelated. A correlation value close to 1 or -1 indicate a strong relationship, while a value near 0 suggests a weak or no relationship. However, correlation does not imply causation. Correlation calculation, example of data set, height and weight, and then we have a correlation matrix, and finally we found the height and weight. The correlation coefficient 0.09844 suggests a strong positive relationship between height and weight. The scatter plot visually confirms this by showing an upward trend. A correlation matrix identify relationship numerically with the scatter plot visually confirm them. A high positive correlation suggests that one variable increase, the other also tend to increase. So Pearson versus Spearman correlation. First is a measure linear relationships, the strength and direction of the linear relationship is between two variables. And if we check the Spearman correlation, the strength and direction of monolithic relationships, meaning one variable increase as the other increase, but not necessary at a constant rate. Then we have a data type, require continuous variable, height, weight, temperature, and then here can be used for ordinal data like ranking, satisfaction level, or continuous data. Sensitivity, highly effective, so sensitive to outlier. A few extreme values can distort the correlations, and then less sensitive to outliers since it ranks the data. Extreme value has less impact. Assumptions, normal distribution of data and homoscedasticity, constant variance of differences. And this side, no restrict consumption about the data distribution, making it more flexible. So simply a Pearson coefficient close to +1 or -1 indicate a strong linear relationship. And the Spearman coefficients close to +1 or -1 indicate the strong monotonic relationships. Even if data points curve, as long as one variable increase while the other increase. So let's have a check the code. Is generate sample data and then compute correlation matrix, and then we have a heat map, and the result will be in this way. Pearson correlation heat map, higher linear relationships. Spearman heat map capture risk-based relationships useful for non-linear trends. And why we use heat map? Quickly visualize multiple relationship at once, useful for failure detection in machine learning. And final thought, data dispersion and variability, quartiles variance and standard deviation measure how data is spread, outlier and their impact. Outlier can distort analysis and should be carefully evaluated. Boxplots and IQR, these visual tools help identify and interpret outliers, standard deviation and variance. Standard deviation is easier to interpret since it is the same unit as the data. Correlation and relationships. Correlation quantify relationship between variables but does not imply. And Pearson versus Spearman correlation. Pearson is the best for linear relationship and Spearman is ideal for ranked or non-linear data. Understanding dispersion, outlier, and correlation is like a GPS for data analysis. Without these tools, decision making can be misleading. Thank you.